degrees, we'll start with what you know, is an angle measurement. Okay, it's circular. Okay. And easy, but it's a distance measurement. Bless you. We can also measure time. I left him in the weight room this morning. Okay. So if I draw a unit circle, how many revolutions is 2 pi units? 1, yeah. Start here, do the circumference in there, right? So that's 1 revolution. Okay. So if I said pi radians, how many revolutions is that? A half, yeah. It's a half, right? Because 1 pi, 2 pi. Okay. This is also 3. So that forms the basis of our conversions from radians to degrees. Okay. So if, are you with me here? I'm kind of giving you everything. Okay. So that's true. Right? 1 revolution is 360 and it's 2 pi radians. Okay, what's our unit conversion going to be? We got to come up with some formulas to convert from the other one to the other. Okay, because it kind of gives you an idea. Like if you look at your unit circle, 45 degrees, how many radians is that? This is, okay. Any ideas on a formula based on that? No? Okay. If I take some number of degrees, what do I need to multiply it by to get radians? You answer that question. Times 2 pi? Okay. This is the conversion factor from degrees to radians. So if I take 360 degrees, right, times pi, divide by 180, what do I get? 2 pi radians. Okay. So when I'm looking at going from degrees to radians, you're always going to put a pi in it. I know this year we eat too much pie. I think I've eaten 2 or 3 the last week, but put a pi in it. Yeah. Okay. So times pi over 180. How would I convert 2 pi radians to degrees? You think of a, what? You're close. I'll give you the bottom, the denominator. 180. There's your conversion from radians to degrees. Okay. 2 times 180 is 360, and then pi over pi is nothing, right? It's 1. So you get rid of the pi. Okay. Bummer. RAD. Radians. Yep. So if you're looking at writing it out, that's what you need to write. Good question. Okay, what about 270 degrees? What is that in radians? Times what? Yep, pi over 180. So we get, what's 270 over 180? Oh, as a fraction. What? Yeah, 1.5. What we usually do is write it 3 over 2. That's 1.5, right? So you'll see it written in fraction form. Okay. Now, if you're looking at your unit circle, the handout I gave you already has the radians on it. Okay. Is 3 pi over 2 radians. Okay. So having both of those in your brain, and hopefully by the end of the year, you're going to be able to just remember radians without even worrying about the degrees. It's like learning a new language. Okay. The first thing you do in Spanish class is learn the comparison of the English to the Spanish, but eventually you can just think in Spanish, right? So that's kind of what our goal is here, to get thinking just in terms of radians. Okay. Because radians is a real number measurement. That's what we use in calculus. That's it. We don't even touch degrees. Okay. For those of you that are going into calculus. Let's see here. How about 3 pi over 4 radians to degrees? Times by 180 over pi. You got to get rid of the pi's. What's 180 divided by 4? 45 times 3. So 135 degrees, I believe. Okay. And that would be right here. Right. Most people are pretty comfortable with that. You think you can handle it? Converting from radians to degrees? And back. Okay. Because we can compare the two of them, we can also use them in the sine, cosine, tangent, etc. functions. Okay. And it's no different than what you already know. You just have to think in terms of radians now. So if I asked you for the sine of 3 pi over 4. That's the same as the sine of 135, right? They're completely interchangeable. So if you look at your unit circle, what's the sine of 135? You're close. Sine is the y value, right? Yeah. So is it positive or negative? Yeah, positive, and it's root 2 over 2. Okay. Remember your reference angle here is 45. And all the 45-degree markers are root 2 over 2. It's just a positive or negative switch. Okay. What's the cosine of 3 pi over 4? That's the negative value for negative x. Okay. So if you need to right now, thinking, take your radians, put them into degrees, that's fine when you're doing this. It's okay with me. But eventually, like I said, we want to get to the point where we're thinking in terms of radians. Okay. For the purposes of the project, the radians are how we're going to measure time. For music, music is in time. Okay, so we need that linear measurement because it's the circumference for time to go on. Okay, so that's why we have radians for music. All right. Any questions so far? Doing okay? All right. Let me make sure. I think there's something else I need to look into. Yeah. If you're interested, on page 344, there's a table, degrees to radians. But like I said, I already gave you the unit circle too, so you can use that. I think that's it. Let me make sure there's not something else. Okay. Yep. Okay, that's it for the day on the mathematical part. So we're kind of well on our way towards being able to graph these. The first thing was to be able to measure in time, right? And what, of course, is this is what a sine wave looks like over time. Okay, so that's where we're headed. Okay, we have some homework for you. I'm going to give you the rest of the hour to work. You can work on the homework, of course, or you can take a computer and start working on your report with your song and your chords. I'm here, so it might be a good idea to have that resource. Okay, let me write that down, and we'll let you get some work done. Okay, so that's all the new stuff. I'm trying to minimize it as much as possible, so you do have time to work on your projects. And then the rest of it's the review material. For purposes of your final, the review material is going to be pretty important because it is a semester final. Okay, so keep that in mind.